Hello parents, welcome to this week's video tutorial for what we are going over in math. As always, since it's taught a little differently now, just wanted to help y'all out with what we are doing so that way you know exactly what the expectation for your child is and how we're solving it in class in case they need a little extra help at home. So what we are doing this week is lattice multiplication. So for the example in this video, we're going to use 349 times 63. So first we will always put the larger digit on the top and the smaller digit on the side, and then we will draw a box underneath. So since there are 3 digits by 2 digits, the box will look like this. So next we're going to draw on the diagonals for every box just like so, and these spaces that are created are going to be used to put in the partial products. So as a quick review from last week, partial products are separating the product out into the place values that the number is created. So for example, using what we have in our problem, the 6 times 9 equals 54. So when it's written out in partial products, you separate it into 50 plus 4. Once again, for the 4 times 6, you'll do separated into place values, which is 20 plus 4, which gives you 24. And then as the last number for that row on top, it's 3 times 6 equals 18. So you'll separate it again into the place values. You'll have the 10 plus the 8, which equals the 18. If your student is still struggling with partial products, have them look over the video from last week under the student tab on our class website. There's also another tutorial just like this one underneath the parent tab for y'all. Now back to our lattice box. We start in the very top right hand box, which is the 9 times 6, which equals 54. Like we just discussed in the previous slide, when you break it into partial products, that gives you 50 plus 4. And so we will put the 5 that's in the tens place on top of the diagonal, and the 4 that's in the ones place below the diagonal. You'll do the same thing for the rest of the boxes, just like so. For the 3 times 3, it is a little more difficult for some of the students since there is not any value in the tens place. So what we do with that is we put the 0 in the tens place above the diagonal and just leave it as the 9 in the ones place. For the next step, we are going to add the diagonals, starting with the very bottom right corner this time. So in class, we go ahead and we just extend the lines out a little bit so we can put our sums underneath them, just like this. So the first number at the very bottom is 7. Since there aren't any other digits in that diagonal, it's 7 plus 0, so we go ahead and write a 7 underneath the diagonal line that we extended. From there, you go to the group right above that, which is the 2 plus 2 plus 4, which equals 8. So you'll write that in the diagonal that we extended again. And then you'll move on to the one on top of that, which is the 9 plus 1 plus 4 plus 5, which gives you 19. Since this number has a tens value and a ones value, we simply write the ones value, which is the 9, underneath our diagonal, and then we carry the tens value to the next group. So the 1 gets put into the group right above it, giving you 1 plus 0 plus 8 plus 2. You'll do the same process for the next two. So as we stated, the ones place goes below the diagonal, and then we carried the 1 from the tens place, and then we simply added that last row together. So now that we have created all of our sums underneath the diagonals, to find our solution, we simply follow along. So the 349 times 63 equals 21,987. The last step is just to write it as a full number sentence, including the solution. So how this slide looks is exactly how your students' homework should look after solving the problem. The box completely filled out with partial products and the number sentence rewritten with the solution. As always, I will be at school every morning and after school for about an hour. If your child is still struggling, they are more than welcome to stop by for some extra help. Thank you and have a good day.